Awesome. So this video is going to be all about Boyle's law and the applications to Boyle's law. We're going to be also doing a practice problem for Boyle's law towards the end. So what is Boyle's law? So Boyle's law is describing the relationship between volume and pressure. So this relationship is an inverse relationship, meaning that if we're increasing the volume, we're going to be proportionately decreasing the pressure and vice versa. All this is assuming constant temperature. So some common units at play when we're talking about pressure and volume. So for volume, we're going to be talking a lot about milliliters and liters. And for pressure, we're going to be talking about torr, mmHg, and atm. So the general equation for Boyle's law is going to be P1 times V1, and we're setting that equal to P2 V2. So this is going to allow us to isolate a single variable using some algebra. And then if you want a more qualitative explanation and demonstration for Boyle's law, we can go over to PhET, so P-H-E-T. It's an animation software used by the University of Colorado. What we can do is, I'll show you this right now. So we're talking about ideal gases. So what you can do is you can play around with the volume, the temperature, and the pressure. So you can play around with this. So let's pump some particles into our gaseous system, right? So as you can see, the pressure is going up. But let's see if we change the volume of the system, because that's what we're talking about, right? So that is going to have an effect, which we're going to talk about shortly. So let's go back to our notes. All right. So we have our general equation that is going to allow us to isolate for a single variable. And we know that when we adjust the pressure or the volume, there's going to be a proportional and inverse change. So let's look at a practice problem. A helium balloon has a volume of 735 milliliters at ground level. The balloon is transported to an elevation of 5 kilometers, where the pressure is 0.8 atm. At this altitude, the gas occupies a volume of 1,286 milliliters. Assuming the temperature is constant, what was the ground level pressure? Okay, so two things stand out to me with this problem. The first is that they include an elevation of 5 kilometers. When we're talking about Boyle's law specifically, we're not going to be worried about elevation. So let's not worry about the 5 kilometers. That's just there to explain why there's a pressure change. So essentially, we're giving a P2, which is this 0.8 atm, and we're given a V2, which is the 1,286 milliliters. So we are given a V1 of 735 milliliters. That's our ground level volume of the helium balloon. What we don't have is the P1, the initial pressure, which is what we're asked to find when they say ground level pressure. So let's scroll down. Actually, if you want to pause the video right now, this would be a good time to work out the solution yourself. Okay, so now we can come back, and assuming that you've tried the problem now, we can scroll down and I can show you how I worked it out. So the first step is always to write the equation down. It's a good way just to remind ourselves what we're looking for. And then we want to isolate for the P1 because that's the ground level pressure we're trying to find, right? So we use some algebra, and we're going to set P1. So we're going to say P1 is equal to P2 times V2 divided by V1. And then we essentially just plug our variables in. We don't need to convert anything as of right now. because we're an SI, and we're going to get a P1 of 1.4 ATM. Okay, so now that we have our understanding that P1 is 1.4 ATM, we can go back to our qualitative approach of Boyle's law. So we know that if the pressure is decreasing, the volume is going to increase, and if our pressure is increasing, then our volume is, or excuse me, if our pressure is decreasing, our volume is going to increase, right? It's inverse relationship. So if our P1 is 1.4 and then our P2 is 0.8, we know our pressure is decreasing. So what does that tell us? That tells us that our volume should proportionally increase. So let's look at our V1. Our V1 is 735 milliliters, and our V2 is 1,286. It increased. So that lines up with Boyle's law, and it confirms our hypothesis. So yeah, that's the video, and I hope that helps.